this video, I wanted to go over one of the features of the TI-30XS that I think is really helpful and is useful in a lot of algebra applications, and that is this button. It's labeled table. I know that's not super clear, but hopefully you guys can see what's going on here. So I'm going to show you 3 different kinds of problems where you might be able to use this table button and how to use it. And the first one is this problem I have here, creating a t-table for graphing. So you can see we have an equation up here at the top, and we want to draw a picture of the graph. And the way we want to go about that for this problem is we just want to pick some x values and then calculate the y values that go with it. That will give us a bunch of ordered pairs that we can use to draw our graph. If we were doing this by hand, we could pick, for example, x equals 0, and then we do the calculations, 0 squared plus 2 times 0 minus 3. We know the y value is -3. But it turns out the calculator can do a whole bunch of values for us nice and quick, and that might be a time saver for you. So first thing you want to do is press that table button. And you'll see I have y equals, I already have something typed in there. So if you have something in there already, you'll want to hit the clear button. And this is where we're going to type in the equation for the problem. So I'm going to type in the x squared plus 2x minus 3. Okay, this button right here to the left of the number 4, that's how we get an x variable in an equation. So that's what I'm going to hit first, x, and then the squared button. So I did x squared. And then we just use our plus and minus keys here, plus 2x. So that was 2 times x minus 3. So there's our function, and then you'll want to hit enter. And then we'll get this little grid of information. What do we want our x values to start with? What do we want them to increase by? And then do we want it to auto-generate a table, or do we want to be able to type in x values? So for this problem, I'm just going to say let's start at x equals -5, and then I hit enter. I want it to go up by 1. I just want whole numbers, and I'm going to leave it on auto. I want the calculator to go ahead and auto-generate a table for me. So then I use my arrow button to go over to OK, and I hit enter. And you can see here I have a whole table of numbers that I can scroll through. We can only see 3 x values right now, but we can actually scroll up or down to see more. So the first point that would be on our graph is -512. That's off the grid here, so I'm going to skip that one. I'm going to go down. The next point they give us is -4, 5. And then -3, 0. -2, -3. -1, -4, 0, -3, and 1, 0. We'll do one more. We maybe didn't need quite this many points. And then we can plot those here on our graph and see what it's going to look like. There's our first point, and our second one, and our third, and our fourth. 0, -3. 1, 0, and 2, 5. And then if we connect those points, we can see, hopefully, as you guessed, it is going to be a parabola because that was an equation with an x squared in it. Okay, and so you can see we could have calculated all those values ourselves, but it just takes a little longer to plug them each in and do those individual calculations. So using the table button can give you a generated table nice and quick. Okay, so here's another problem that you could use a table button for. On this one, we are asked to solve we could use it for polynomial or rational inequalities. This one is a rational inequality. So we are looking for what kind of x values could I plug in here so that this expression gives me numbers greater than 0. Okay, so when we need to solve a polynomial inequality, the first thing we want to do is find our boundary points. Oops, sorry about that. Boundary points, just to refresh, are where this rational expression over here is equal to 0. So that's where the numerator equals 0. Or where this rational expression is undefined. So that would be when the denominator equals 0. Okay, so we have 2 little equations here. We'll solve each one of them. This one gives us 2x equals 4, x equals 2. And here it's already factored, so that's nice. We know that either x plus 1 has to be 0, or x minus 4 has to be 0. So we get 2 values here, x equals -1, and x equals 4. Okay, so these are the points, the x values, where this expression, this rational expression, is either 0 or undefined. So if we put those points on a number line, it doesn't have to be to scale, we just put them in order from smallest to biggest. Okay, those are the 0 or undefined points. So we are interested in what is the sign in between those x values. Okay, so we can create a sign chart, or we can use our little table function to help us out with that. So if we hit the table button again, clear out what you had in there before. This time we're going to enter a rational expression. So we need, I keep hitting the mouse, sorry about that. We need this fraction button right here. So that'll give us a fraction. Up top, we have 2x minus 4. Use your arrow to go to the denominator. In the bottom, we have x plus 1 times x minus 4. So there's our rational expression. I hit enter. This time, instead of doing auto, I'm going to have it ask me what values I want to use for x. So I'm going to be able to type in the values I want to see. So I move my cursor over to ask and hit enter. And then I move down to OK and hit enter. There are some numbers in there already, but let's type in our own numbers. So what we need to do for this number line, we need to pick an x value that is less than -1. So maybe our test point for this interval would be x is -5. Okay, so you see I already have a -3 here, which also would have worked for a test point. But if I type in -5, it goes right there, and I hit enter. You can see the y value for x equals -5 is -7/18. I don't actually care about the 7/18, I care about the sign. My rational expression is going to be negative in this interval. Next, I pick a test point between -1 and 2. I always like to use 0 when I can. Oh, and I already have 0 typed in. You can tell I actually worked this problem before. So let's type in a +1 just so we can type in a new number. If we put a 1 and hit enter, there's for x equals 1, y is +1/3. So that means that rational expression is going to be positive in this entire interval. Then we need a test value between 2 and 4. X equals 3. When I type in 3, you can see the y value is -1/2. So we're negative in that interval. And then I need an x value in this interval, something bigger than 4. Maybe x equals 6. For x equals 6, we get a +4/7. Okay, so that's a quick and easy way to generate our sign chart. Just to finish out the problem, since this was looking for when is the rational expression greater than 0, that would be these positive intervals that we just calculated here. So our answer would be that rational expression is greater than 0 when x is between -1 and 2, or when x is 4 or bigger. That would be our final answer. Okay, one more problem. I'm going to show you how to use the table button to factor a trinomial. Okay, so if we need to factor a quadratic expression, we would use factoring when we were solving a quadratic equation. We might use factoring when we were adding or subtracting rational expressions. There's a lot of cases in algebra. It's kind of one of the most common things you do in algebra is factor. For this first expression, this one is actually pretty easy to do by hand. To factor this, we would be looking for two numbers that have a product of -7 and a sum of -6. Well, -7 can only be made one way. It's either -1 times +7 or -7 times +1. So to get that -6 sum, our signs would have to go like this. So we can see pretty easily that factors into x plus 1 and x minus 7, not too bad. But if we move to the second one over here, we factor that x squared gets broken into x times x. This time we are looking for two numbers that give me a product of -648 and a sum of 18. Now, I'm even a math nerd, and I don't want to think about what factors of 648 are going to add up to 18, right? That would have a ton of different factors. So here's how we can use the table button to solve this problem for us. So hit that table button again, clear out what we had in there from the last time. And what we're going to do is we're going to take this number at the top, the product that we're looking for. I always just use the positive version. I'm not going to worry about the sign yet. So type in that number and divide it by x. Okay, so we are typing in there 648 divided by x. And what that's going to do is that's going to give us a list of factors. This time we want to start at 0 because, again, I'm only going to look at positive numbers. We'll worry about the signs in a minute. We want to go up by 1, and we want this to auto-generate. We don't want to type numbers in. We just want to see that whole table. So arrow down and hit OK. And you can see what we have here is now a list of factors of 648. 1 times 648, 2 times 324, 3 times 216. So what we have to do a little mental math here and think about which pair of numbers is going to add or subtract to give me this positive 18 that I'm looking for. Well, right now you can see I'm really far apart. If I do 216 minus 3, I'm still at 213. That's nowhere near where I want to be. So I'm going to have to scroll through here. Anytime you see a decimal, ignore those. We're not going to factor with decimals. So we're only looking for whole numbers. Let's see here, and here we go, 18 and 36. I can think about it in your head or do it by hand or do it on the calculator. 36 minus 18 does give me that 18 that I'm looking for here. So that means it's got to be a minus 18 and a positive 36. Again, you have to think about those signs, but the table button can help you find those factors on big numbers like this when it might not be quite so easy. Okay, so that table button can save you some time and check your arithmetic on all kinds of different problems you might do in an algebra class.